Welcome, focused learners. Today we're tackling a massive explainer on Chapter 1 of the HSC ICT syllabus. If you've been staring at your textbook feeling totally overwhelmed by how all this modern tech connects, and more importantly, how you're actually going to be tested on it, you are in exactly the right place. We're going to break this whole thing down so you can absorb it effortlessly and actually see how these concepts are shaping our world.
Which brings us to the real question, right? How do you actually master HSC ICT and crush those board exams? Look, the National Board doesn't want you to just blindly memorize dictionary definitions anymore. That won't cut it. They want to see if you can take a complex, real-world scenario and figure out what tech is being used. And honestly, that is exactly what we're going to hack today. Okay, let's dive into this. Here is our roadmap for today. We'll hit Chapter 1, Top Technologies, Board Exam Success Strategies, Virtual Reality in Daily Life, How Artificial Intelligence Works, Inside Artificial Neural Networks, and finally, Biometrics and beyond.
Section 1, Chapter 1, Top Technologies, the Modern Transformation.
So this whole chapter is basically about how digital advancements are completely rewriting human civilization. Your NCTB textbook lays out 8 main pillars driving this. We're talking about the global village, virtual reality, artificial intelligence, robotics, cryosurgery, biometrics and bioinformatics, genetic engineering, and nanotechnology. These 8 are literally the foundation of our digital world, so you absolutely need a rock-solid grasp on them.
Section 2, Board Exam Success Strategies, Hacking the Test.
Okay, knowing the tech is great, but securing those top marks, that requires strategy. Based on past trends, here's a highly tactical 3-step game plan for you. Step 1, read the textbook line by line to catch all those sneaky small definitions. Step 2, solve at least 5 years of past papers. Seriously, this is critical for spotting the patterns that repeat year after year. And Step 3, master those creative exercises at the end of the chapter. Exam setters heavily rely on those when building your test.
So the crucial point here is that rote memorization is a dead end. You can't just copy-paste a definition onto the page and expect an A. The exams are going to give you a hypothetical scenario, and you have to identify the tech based purely on its application. Like, if you read about a doctor doing surgery from 1,000 miles away, boom, you need to instantly recognize that as telemedicine or a function of the global village. It is all about application, guys.
Section 3, Virtual Reality in Daily Life. Beyond the headset. We're kicking things off with VR because, well, it's heavily tested. And that's because its real-world applications are literally everywhere. Let's define it simply. Virtual reality is an artificial 3D world generated by a computer. Imagine strapping on a specialized headset, slipping on some sensor-equipped gloves, and stepping into a completely immersive digital space where you interact with things exactly as if they were physically right in front of you. It's wild.
Now, often paired with VR is this idea of simulation. A simulation is basically a digital model of a real complex process. It acts like a giant, risk-free sandbox for training. Think about pilots in flight simulators, or surgeons practicing tricky laparoscopic procedures digitally. It lets them crash a plane or mess up a surgery with absolutely zero real-world consequences.
And you'll frequently be asked to compare the impacts of VR on the exam. On the plus side, we have massive benefits. Stuff like advanced medical training, safe flight prep, or perfectly planning out architecture before a single brick is laid. But there's a flip side. Excessive VR use can lead to severe technology dependency. People can get so sucked into their own imagination and this digital space that they risk a very real, dangerous loss of touch with physical reality.
Section 4, How Artificial Intelligence Works, From Data to Decisions.
AI. It's the ultimate buzzword right now, isn't it? But at its core, it's really just a branch of computer science. It gives machines the ability to think, learn, and make decisions, kind of like we do. Instead of just blindly following some rigid, pre-programmed rules, AI can actually adapt and solve problems dynamically.
To really wrap our heads around this, let's break the AI process down into 4 steps. First up, data ingestion. This is where immense amounts of data, millions of pictures, text files, whatever, are fed in. Second is training, where the machine uses algorithms to hunt for patterns in all that data. Third is inference. This is the payoff, where the trained AI uses what it learned to actually make a decision. And finally, the feedback loop, where human feedback steps in to correct mistakes so the AI keeps getting smarter over time. Let's ground this with a relatable scenario. When you're chilling on YouTube and it recommends the absolute perfect video, that is AI in action.
It ingested data from millions of users, trained on what people like, and inferred that based on your specific viewing habits, you'd probably click that thumbnail. It's just pattern recognition powering the apps you use every single day. Section 5. Inside Artificial Neural Networks, the core code.
Let's move to and see how this builds, zooming right into the mathematical brain of machine learning, the artificial neural network. It's actually heavily inspired by how the neurons in a human brain work. It operates across 3 distinct layers. You've got the input layer, where your data enters the system. Then the hidden layers. This is where the really complex mathematical pattern processing happens. And finally, the output layer, which generates the final predicted result.
But here's the crazy part. The magic happening in those hidden layers, it's mostly just matrix multiplication. Seriously, it comes down to a core equation. Y equals WX plus B. X is the input data. W stands for weights, which literally represent the machine's learned knowledge or how much importance it gives to certain data. B is a bias to adjust things, and Y is your final output. During training, the AI is essentially just fine-tuning those weights millions of times until it gets the answer right. But what happens when it completely messes up? The gap between the wrong answer and the right one is called loss. To minimize this loss, the AI uses advanced calculus, specifically backpropagation and gradient descent. Think of it like a student totally bombing a test question, looking at the right answer and changing how they study. The AI rolls backward through its layers, figures out exactly which weights cause the error, and tweaks them slightly so next time the error is closer to 0. It automatically learns from its mistakes.
Section 6. Biometrics and beyond, identifying and analyzing life.
All right, let's zoom back out from the heavy math for a second, because tech isn't just screens and data, it's biology too. Let's look at bioinformation. This is the science of using computers, mathematical models, and statistics to store and analyze incredibly complex biological data. If researchers are studying DNA sequences, RNA, or trying to decode proteins to cure disease, they are absolutely relying on the massive processing power of bioinformation. Now here is a massive cheat code for your exams. You have to carefully contrast bioinformatics with biometrics. Don't mix them up. While bioinformatics is all about analyzing data for scientific research, biometrics is a security technology used to physically or behaviorally identify a specific human, like scanning a fingerprint or a retina. It follows a simple 4-step process. Capture the data, extract the unique features, compare those to a stored database, and finally, make a match.
And this brilliantly illustrates our last stop today, nanotechnology. We are shifting completely to the absolute smallest scale of tech here. Nanotech is engineering matter at the atomic or molecular level. By manipulating materials at this microscopic scale, scientists are unlocking revolutionary breakthroughs, from highly targeted microscopic medical treatments to ultra-fast tiny electronics. We have covered immense ground today, from the core code of neural networks to the atomic scale of nanotech. But I want to leave you with a final thought to ponder, for your exams and honestly, just for life. As AI and VR aggressively accelerate human civilization, are you ready to balance your reliance on these incredibly powerful tools with your own irreplaceable human critical thinking? Master these concepts, apply them to the real world, and you are absolutely going to crush your board exams. Thanks for hanging out with me for this explainer, and keep learning.